Hello 3D printing friends. Today on the BV3D channel we are going to unbox and assemble and maybe get a first print out of the JGMaker Magic 3D printer. Stick around and we'll get into it right after this. I'm Brian and you are watching BV3D. Hi, welcome back. Hey, if you're new here and you're wanting to learn about cool 3D printer upgrades, 3D modeling, and other 3D printing related stuff, start now by subscribing and clicking the bell so you don't miss anything. Okay, so today we are going to unbox and assemble and maybe get a first print out of the JGMaker Magic 3D printer. Now it's interesting how this came to be in my possession. Back in June, JGMaker had a Father's Day giveaway and the prizes were 5 spools of filament and a JGMaker Magic 3D printer. So 5 people each won a spool of filament and 1 lucky person won the 3D printer. Now coincidentally, a recent question posed to the 3D printing community on Twitter asked whether people still entered giveaway contests to win printers, and my response was, I do. I mean, I know I won't win, but I still do it. And JGMaker's giveaway was one of those that I entered. I'm glad I did because I won the printer. So shortly before Father's Day, this arrived on my doorstep. And this box purportedly contains what can only be described as magic. Because that's the name of the printer, the JGMaker Magic. Now I get the impression this printer has been around for at least a year and a half based on what I've seen online. But despite that, I'm going to do that thing that one does when one gets a new 3D printer. I'm going to make an unboxing, build, and first print video. So here's how I'm expecting this to go down. I'm going to take all the stuff out of the box and get it all laid out here on the workbench. And then I'll probably be commenting on each item as I take it out. When everything is out of the box, I'll arrange it all neatly on the bench and get a nice shot of it all. After that, I'll do a step-by-step assembly of the printer, and once it's done, I'll power it on, make sure that all the parts move like they should, and then I'll level the bed. Yes, I know I should probably say I'm squaring the printer or tramming the bed, but leveling is still the term that's sort of embedded in the 3D printing lexicon. I know it confuses people. It confused me when I got my first printer, and I tried to make sure the bed was actually level with the earth. And I couldn't understand why that would even matter. And then eventually I learned that it doesn't matter. Because the idea is to make sure that when the Z-axis is homed, the nozzle is the same height above the bed across the bed's entire surface. Okay, fine. So if tramming is the right word, then that's what I'll say. After it's built and it looks like it's happy, I'll tram the bed, and then I'm assuming that there's a pre-sliced test file or two on the SD card that comes with the printer, so I'll print that, and then we'll see how well it prints. So without further ado, I'm going to open this thing up and start taking the parts out. I'm not going to have enough room up here, am I? Tell you what, I'm going to take this box and set it right aside, and then I can just take stuff out. Just a second. That'll work, right? Okay, here we go. All right, first up, we've got a bag of parts. Got the quick start guide, got tools and screws, and this is basically all of the hardware, so I'll set that right there. We have our US standard power cord. We have the fully assembled spool holder. This thing is well packed. Let's take the main base out first, but there's stuff attached. Okay, it's just cables. There we go. Okay, so this is the printer base, and I'm kind of disappointed in that. Why is there not a cover on the base of this thing? All right, I'll set that right here. Well, now that's not bad. The entire X gantry is pre-assembled except for the belt. I'll set this here. We have the X carriage with the hot end and all of its cables attached. We have the Z-axis uprights with the stepper motor pre-attached. So that's everything that was in the box. So we're now done with that unboxing part, and I will get these laid out nice and neat, and we'll start getting this thing put together. Okay, so here's everything that comes in the box. There's the printer base unit, which is already assembled and it has a clip-on removable print surface. There's the spool holder. There's the pre-assembled X-axis gantry. Now on older editions of this printer, that was something that you had to assemble yourself. So having it factory assembled is a real time saver. Then there's the power cord. There is the X carriage with the hot end and the fans and the wiring and the Bowden tube. There's the Z-axis aluminum extrusions with the Z-axis stepper motor already bolted on. And again, on older editions of the printer, you had to bolt that on yourself, so another time saver. And hiding inside one of the Z-axis extrusions was the Z-axis lead screw in a plastic bag, and it's already lubricated. There's also the crossbar for the top of the Z-axis and a metal trim piece with the JGMaker logo silk screened on it, which covers that crossbar when the printer is all assembled. Over here on the Wham Bam slap mat is the contents of that parts and tools bag that I first removed from the box. Starting back here, there is a spare parts bag which has extra screws, T-nuts, zip ties, a nozzle, and what appears to be a spare fan connector. There is a thin spatula for getting under the edge of a print if you need to pry it up off of the print surface. Here are all of the screws needed to assemble the printer, and all the bags are labeled in both English and Chinese. There's also a small bag of tools which contains a couple of wrenches along with a set of Allen keys. They're not the ball end type, but that's okay. There is a USB card reader and the printer's SD card is contained within. There's the X-axis belt, which gets installed when we put the X carriage on the X-axis gantry. There's the filament runout sensor. There's the Z-axis limit switch. And there is a spare filament loading lever for the extruder in case the one that's already on the printer breaks. That is a nice spare part to have. Then there's the USB cable, a tiny coil of filament, the warranty card, and the quick start guide. And then there's this. This cardboard sleeve contains the flush cutters like you get with every 3D printer because they're great for cutting zip ties and filament. But I want to talk about these flush cutters for just a minute because it says right here on the carton that these are made in the USA. So think about that for a second. Cartons of these flush cutters were made in America, shipped to China on a cargo vessel, where they were then delivered to JGMaker, who unpacked them, repacked them with the printers, and then shipped them on a cargo vessel back to America. These flush cutters have literally been halfway around the world and back. And I find that kind of amazing. Okay, so this is the part where I start doing the printer assembly. So coming up, I'll show the parts needed for each step, show you how to complete that step, and bit by bit, it'll get put together. This assembly is going to be easier than I first expected since the X-axis parts are already put together. Ready? Here we go. For this step, you will need the following components: the X carriage, the assembled X-axis gantry, and the X-axis belt. Slide the X-axis belt into the top V slot on the X-axis gantry with the toothed side of the belt facing down into the slot. Slide the X carriage onto the X-axis gantry starting from the right side of the gantry. It's the side with the stepper motors. The top of the X carriage is where the cable bundle and PTFE tube are attached, and the top of the X-axis gantry is where the extruder is. So make sure the tops are both on top. Loop one side of the belt around the idler pulley and connect the loop on the end of the belt to the hook on the left side of the X carriage. Loop the other side of the belt around the motor's toothed pulley and then connect the loop on the end of the belt to the hook on the right side of the X carriage. Loosen the two screws securing the belt tensioner. Push the tensioner to apply tension to the belt. While maintaining tension, tighten the screws to secure the tensioner in place. Make sure the X carriage moves smoothly on the X-axis gantry. For this step, you will need the following components: the Z-axis limit switch, 4 M5x40 screws, the 2 Z-axis aluminum extrusions, one of which has the stepper motor attached, and the printer base unit. Attach the Z-axis limit switch to the aluminum extrusion which has the stepper motor. Loosen the screw attached to the T-nut and mount the switch just above the motor's bracket, with the switch's lever facing away from the motor. Tighten the screw to secure the limit switch. Attach the extrusion with the stepper motor to the right side of the printer. The motor should face the rear of the printer. Insert 2 of the M5x40 screws into the screw holes in the extrusion, then tighten them using an Allen key. If you have a small square available, you can use it to ensure that the extrusion is square with the base. Insert the other 2 M5x40 screws into the other aluminum extrusion. Note that the holes are drilled out larger on one side to accommodate the screw heads. Attach the extrusion to the left side of the printer. Tighten the screws using an Allen key, and again, you can use a square to ensure that the extrusion is square with the base. For this step, you will need the following components: the printer base with the Z-axis extrusions attached, and the assembled X-axis gantry. Slide the X-axis gantry over the Z-axis aluminum extrusions. The hot end assembly should be toward the front of the printer. Allow the X-axis gantry to rest on the bed. For this step, you will need the following components: the printer so far, the top crossbar aluminum extrusion, the JGMaker trim piece, 4 M5x25 screws, and 2 M5x8 screws. The screw holes on the top of the crossbar have been drilled out a little larger on one side to accommodate the screw heads. Insert the 4 M5x25 screws into the screw holes. Using an Allen key, begin tightening the 4 screws, but not all the way. They need to be a little loose right now. Ensure that the left edge of the crossbar is flush with the left side of the Z-axis extrusion, and tighten the 2 screws on the left side of the crossbar. Slide the X-axis gantry to the top of the Z-axis to set the spacing of the 2 Z-axis extrusions. While holding the gantry with one hand, tighten the screws on the right side of the crossbar. Then allow the X-axis gantry to rest on the bed. Attach the JGMaker trim piece to the top crossbar using the 2 M5x8 screws, one on each side of the crossbar. For this step, you will need the following components: the printer so far, and the Z-axis lead screw. Loosen the upper set screw on the coupling attached to the Z-axis stepper motor. Insert the lead screw through the threaded nut located by the extruder. And then into the coupling on the Z-axis stepper motor. Tighten the upper set screw on the coupling. For this step, you will need the following components: the printer so far, the filament sensor, the spool holder, 2 M3x8 screws, and 2 M5x8 screws. This is the filament sensor, and it goes in this orientation with the arrow showing how to insert the filament. Using the 2 M3x8 screws, attach the filament sensor to the angled part of the extruder stepper motor bracket. Using the two M5x8 screws, attach the spool holder to the right side of the printer. For this step, you will need the following components: the printer so far. Insert the end of the Bowden tube from the hot end into the fitting on the extruder. Plug the connector labeled E motor into the extruder stepper motor. Plug the connector labeled X motor into the X-axis stepper motor. Plug the connector labeled E switch into the filament sensor. Plug the connector labeled Z motor into the Z-axis stepper motor. Plug the connector labeled Z switch into the Z-axis limit switch. Insert the cable from the hot end into the cable grommet with the other wires. The hot end cable will be connected in the next step. For this step, you will need the following components: the printer so far. Place the printer on its left side. Plug the cable from the hot end into the printer's main board. Find the input voltage selection switch on the power supply located on the underside of the printer. Set the switch to match the available power. In the United States, this is generally 115 volts. Return the printer to its full upright and locked position. Turn the bed height adjustment knobs so that the springs are evenly compressed about halfway through their range of travel. Loosen the screw securing the Z-axis limit switch and move it to its lowest position. Rotate the coupling on the Z-axis stepper motor to lower the nozzle until it's just touching the bed. Adjust the position of the Z-axis limit switch so that its lever is pressed by the X gantry. Then tighten the screw to secure it in place. For this step, you will need the following components: the printer, the power cord, and a sheet of paper. Ensure the power switch is in the off position. Remove the warning tape from the power socket at the back of the printer, then plug the power cord into the printer. Plug the other end of the power cord into a power outlet. Turn the switch to the on position. Using the printer's control panel, set the bed temperature to 60 degrees and let it stabilize for about 5 minutes. Then home the printer. After homing, the level corners item becomes available, so select that. The printer moves the nozzle to the front left corner of the bed, where you can use a sheet of paper to set the distance between the bed and the nozzle. When you can feel a bit of friction between the two, select Next Point on the printer's control panel. Each time you select Next Point, the printer moves the nozzle to each of the remaining corners in turn, and then to the center of the bed. At each point, use the sheet of paper to set the nozzle distance. When you're done, select Back on the control panel. Okay, so the printer is set up and it's ready to print. I'll load that tiny sample coil of filament and I'll print the test file that's on the printer's SD card. I'm hoping there's enough filament here to do the job. I'll heat the nozzle to 200 degrees and once it's hot, I can start feeding filament. I'll insert it into the filament sensor and then into the extruder. I'll keep pushing the filament until it starts coming out of the nozzle. So with the filament loaded, I'll insert the SD card into the side of the printer. The card goes in upside down. Then from the control panel, I'll select the file from the card and start the print job. And hey, it's done! And there was enough filament. There isn't enough left over to do it a second time, but there was enough for that one print. And here it is. Now it printed on a raft, but I've removed that. So right off the bat, there are a couple of things that I notice. First off, there's a couple of layers where the printer had a serious under extrusion issue. And the top surfaces of the print look kind of rough. Now in some spots the layers look really good, but then in others there's these weird surface artifacts, little blobs and stuff. The underside of the print looks about how you would expect for something that printed on a raft, so that part of it gets a pass. But overall, for a brand new printer, I'm not super impressed. Well, let's change the subject for a bit. How about we talk about the printer's features? Its build volume is 220 by 220 by 250 millimeters. It has a maximum nozzle temperature of 240 degrees C and a maximum bed temperature of 110 degrees C. It has a Bowden drive extruder. It uses smooth rods and LM8 UU bearings for the bed, and it uses the V-slot aluminum extrusions and the wheels for the X and the Z axes. It has a full-size SD card slot, a full-size USB Type-B port, and it's priced about the same as the Ender 3 Pro. Okay, now it's time for some thoughts and observations. Now, there are some things about this printer which to me really stand out. Some of these are good and some are maybe not so good. So in the interest of ripping off the Band-Aid quickly, I'm going to get right into the not so good things. The underside of the printer is exposed and unprotected. Now, while the power supply does have an injection molded cover to protect its power input and output terminals, the main board is completely unprotected. Why? Could you imagine buying a Blu-ray player or a game console or any other electronic device without a bottom panel and its circuit boards exposed? Please, JGMaker, add a bottom panel to this printer. Something else that I noticed is that the user guide on the SD card that comes with the printer is out of date. Several of the assembly steps have already been done for you, but you're left to puzzle out on your own which steps you can skip and which ones you still have to complete. Now this could be forgiven to a certain extent if it was a printed manual, but it's a PDF, so there really isn't a good excuse for why it wasn't updated when JGMaker decided to have more of the printer pre-assembled. Now I realize I sound like I'm complaining that I had to do less work to put the printer together, but I'm thinking in terms of what someone might encounter if this were their first 3D printer. The documentation needs to match as closely as possible the product that was purchased. For example, the firmware includes an assisted bed leveling routine that moves the nozzle to each of the 4 corners. And this is phenomenally useful, but the user guide doesn't mention it at all. Instead, the user guide walks the user through a manual bed leveling process. Tramming process. I still have a hard time not saying leveling. Now the SD card contains an incredibly ancient version of Cura, and it also contains a less ancient version of Cura, and the SD card has a PDF showing how to configure Cura to work with this printer. But this is another instance where the documentation that comes with the printer doesn't do you any favors, because more recent versions of Cura, I have version 4.6.1 installed, include a printer profile for the JGMaker Magic. It's listed as the JG Aurora JGMaker Magic, but all you have to do is pick that printer from the list and you're good to go. Now the default settings have supports enabled and they print with a brim, but those settings can be turned off, and apart from that you don't have to do anything else to use Cura with this printer. Now, with regard to how the printer actually functions as a printer, I had some print quality issues. Most notably, under extrusion. Now, we saw this with the pre-sliced sample file that JGMaker included on the printer's SD card. There were a couple of layers where it looked like it barely extruded at all, but most of them printed just fine. And there were also some blobs on the outer surface of the print, so overall it wasn't a good demonstration of what the printer might be capable of. Now, I wanted to see if the under extrusion issues were related to the teeny tiny filament sample or to the pre-sliced file. So I loaded up some Alien 3D Alien Ooze PLA and I set up Cura for the Magic. Then I sliced and printed a 20mm XYZ calibration cube. And again, the resulting print suffered from under extrusion. So just to see if the Alien Ooze PLA was the problem, I sliced the cube in Cura again, this time for the Ender 3 Pro, and I moved the filament over to the Ender 3 and I printed the file there. And the cube printed perfectly, so the filament isn't the problem. There's clearly something going on with this printer. Now, I'm confident that I'll get it solved, but if this were my first 3D printer, I wouldn't be pleased. My last little issue with the printer is something that it feels like I'm always complaining about, and that's the noise level. The fans on this unit are on the loud side. Now, they're not quite as loud as a stock Ender 3, but it's close. It has the same kind of power supply with the always-on fan, so that, combined with the hot-end fan, are a constant source of noise when the printer is turned on. And the printer's metal body seems to resonate loudly when the stepper motors move. This is especially noticeable during longer moves, such as when homing the printer. But that's pretty much all of the not-so-good things. So to counter them, here are some things that are good. Number 1 on the list of things that are good about this printer is that it has thermal runaway protection enabled. I tested this using the USB power method that I covered in my testing for thermal runaway safely video. So yes, this printer does have its thermal safety features enabled in its firmware. And speaking of firmware, this printer is running Marlin. Now, it's not running Marlin 2, it's one of the 1.x releases. And JGMaker is respecting Marlin's open source license terms. So in addition to a precompiled firmware file, they also have the source code available. If you are so inclined, you can download that source code, make changes, compile it, and then upload it back to the printer. Now, despite the safety issues around having the underside of the printer uncovered and exposed, that did allow me to see that JGMaker is using crimped ferrules on the power connectors. And this is a good thing. It can reduce the risk of power inputs having issues with increased resistance and overheating over time. And I find the overall appearance of the printer to be nice as well. It reminds me very much of what might happen if my Monoprice Maker Select Plus and my Ender 3 got married and started a family. It has a base like the Maker Select Plus, although the Maker Select Plus has a bottom cover, and it has the Maker Select Plus bed riding on the smooth rods and the LM8 UU bearings. From the other side of this fictional family tree, it has the Z-axis and X gantry of the Ender 3 and the Bowden drive system as well. So overall, I find it to be a nice looking printer that has a few issues that JGMaker needs to address. In particular, I think having a cover on the underside of the printer is a must, and I think the user guide needs to be updated so that the assembly steps match the actual printer that you receive. And I think JGMaker needs to update the part of the manual that deals with bed leveling. Tramming. Leveling. The firmware included with the printer has an assisted leveling routine, and the manual should show how to use it. Also, JGMaker should include a more recent version of Cura, which has a printer profile for the Magic. By doing these things, JGMaker could reduce the page count in the user guide while at the same time improving the first-time owner experience. Now, I'm still kind of unhappy about the first couple of prints that I've gotten out of this printer. So, did I just get a bad one? I think that the problems that I'm experiencing with under extrusion on this printer are specific to this particular unit. I think if under extrusion was a common issue with the Magic right out of the box, particularly given how long the Magic has been on the market, there would be all kinds of yelling showing up in a Google search, and I'm not seeing that. So I'm inclined to believe that it's an isolated thing. Now, if you have a JGMaker Magic, I'd like to know what experiences you've had with it. Leave a comment down below and let me know what you think of yours. Now, the Magic may end up being an interesting little project printer once I get the extrusion issues worked out. It's got a lot of potential for upgrades. The base is very roomy inside, so I could mount a Raspberry Pi in there running Octoprint, controlling some relays, maybe an LED strip, or all sorts of other things. Heck, I could probably rig the Raspberry Pi and a relay to switch the 24 volt for the printer's main board And then the Pi could take care of turning the printer on when starting a print job and turning it off when the job was done. So, despite the issues, this could be fun. Looks like I've got a lot to think about. And so on that note, 3D printing friends, I think that's about all the time we have for today. And now that we're at the end of the video, let's go print something cool. Hey, real quick before you go, I wanted to say thanks for being one of the super awesome people who sticks around all the way to the end, and thanks for all the likes, comments, and shares. You're all wonderful for doing that, and I really appreciate it. If you liked this episode, a thumbs up would be great. And if you'd like to help support the channel, check the description for ways you can do exactly that. Don't forget, whether you're interested in buying things that were featured in this video or just buying things online in general, there are links in the description to get you to the right place. And I've got some other videos here that you might want to take a look at too. Also, please consider subscribing if you haven't already done so. Subscribing is absolutely free, and it's an excellent way to help keep me making these videos for you. Well, that's it for this one. Thanks again, and I'll see you next time here on the BV3D channel.